Okay, so now we are moving to our next chapter, which is linear second order. Right? So we are going to proceed with second ordinary differential equation. Second order ordinary differential equation, right? So remember, how can you determine the order of differential equation? Number of degree? No. You have to take a look at the highest exponent highest differential, right? You have to take a look at the highest differential. Okay, so here we have the general form of linear differential equation. So this is the general form. an dn y x and an minus 1 dn minus 1 y dx and minus y until a naught y equals to fx. So those a naught, a1 up until an here are called coefficient, and function is fx is a function of x. Okay, so fx here, when fx here equals to 0, then we say that it is a linear homogeneous. When fx here does not equal to 0, then we say that it is non-homogeneous equation. Okay, so we are going to focus on linear second order differential equation. So the differential equation here is second order, which is clarified by this term. You have to take a look at the highest derivative. You know that the highest derivative here is d squared y. So you know that this is second order. Okay. All right, clear? So these are the basic definition and terminologies of linear second order differential equation. First, its general form. All right, this is the general form. But since we are focusing on second order, so we have up until d squared y dx squared here. Okay, and we have a naught, a1, an here are coefficient, function, x here in terms of x, right? And if your right hand side is in terms of function, we say that it is a linear homogeneous. Then if your function in your right hand side fx does not equals to 0, then we call it as a linear non-homogeneous. Okay, so the idea here is second order, linear second order, and homogeneous or non-homogeneous. All right, so now how can we find the solution? Okay, so usually if you have up to second order, you are going to have two solutions. So the total solution, the final solution, should be a combination of the solutions, all right, which is called by linear combination of solution. Okay, if y1 and y2 are linearly independent and each of them are the solution for the differential equation, then the general solution is given by this expression where it is a linear combination of solutions. Okay, so since we have up to second order, usually we're going to have up to two solutions, right? We are going to take a look after this. What are the types of solution? And if you have two types of solution, you combine them together, then we just say that the general solution is the linear combination of the solutions. All right, is that clear? So if we have up to n solutions, then instead of two solutions here, we are going to have up to n number of solutions. We just have to combine them. Okay? So first, linear differential equation. All of you know linear differential equation. Now, second order linear differential equation. Okay? And there are two types, linear homogeneous and linear non-homogeneous. Where linear homogeneous, in your right hand side, there is a function. For linear non-homogeneous, for linear homogeneous, in your right hand side, your function is 0. And for linear non-homogeneous, your right hand side function is not equals to 0. Means there is a function in terms of constant, in terms of linear, quadratic, trigonometric, and so on. Okay, so those are the basic terminologies of the second order differential equation. All right, any question? All of you are clear?
Clear, Doctor.
So how many types of linear second order differential equation that we're going to discuss for this chapter? Two, okay? Where it is linear homogeneous, where function equals to 0, and non-homogeneous, function does not equals to 0. Okay, and if you have two solutions, then you just combine. If you have up until n solution, then you just have to combine by using linear superposition principle. Okay, so that is the basic idea about this topic. Okay, now, how can we solve? You know that this is the form of second order. This is the form of second order differential equation. Okay, now, how can we form the solution of this differential equation? Okay. It's quite easy actually. All right, so now we have second order homogeneous. Okay, let's focus on homogeneous part first, where the right hand side equals to 0. Okay, so this is a second order homogeneous equation. A d squared y dx squared plus b dy dx plus cy equals to 0. Okay, now our aim is to find the solution. Okay, assume the solution is in the form. So let's assume the solution is in the form y equals to emt. Then, if y equals to emt, dy dt is memt. And d squared y dt squared is m squared emt. Okay, so this is just our assumption. Okay, now, if the solution to 1 here is y equals to e to the power of mt, thus it must satisfy the first equation. Therefore, if we substitute all the terms in 2 to 1, we obtain the characteristic this. We obtain the auxiliary equation, the characteristic equation. Okay, so instead of this, by assuming the solution of y equals to e to the power of mt, now this second order differential equation is converted, is changed to characteristic equation by am squared plus bm plus c. So now, in order to solve the second order linear homogeneous equation here, we are going to solve this quadratic equation, where what is our m? M is what? By the solution of this. Okay, so now solving this will give you values of m, of course. So when m here are real and distinct, okay, when m here are real and equal, where m here are complex conjugate, there are certain form of the second order differential equation. Okay, let's take a look. So now, first one, if the roots are real and distinct, the general solution of second order differential equation is given by this. Okay? And if roots are real and equal, the general solution is given by this. And if the roots are complex conjugate, the solution is given by this. Where does this solution comes from? By this assumption. Okay, we use this assumption, we differentiate so that we can substitute to the differential equation, we find m, and then we can identify the solution by using the form of equation for each of the m solution types. All right, let's take a look at the first example here. Okay, is that clear? Right, so we have second order differential equation. We have second order differential equation. Okay, the right hand side is 0, then it is linear homogeneous second order differential equation. Okay, now in order to solve this, first you need to convert to characteristic equation where it can be formed into am squared plus bm plus c equals to 0. Solving this will give you the values of m1 and m2. Why two values? Because this is quadratic. Okay, so now we have to identify types of roots. If both values are real and distinct, then the solution is AE m1x plus BE m2x. If both values are equal, real and equal, then the solution is y equals to EMX, A plus BX. Okay, because M there. Is it right? And then the last one, if both values of M1 and M2 are conjugate in terms of Y alpha plus minus beta J, sorry, M, then the solution is exponent. Exponent, is it? No, not exponent. It is exponent, yes. Exponent alpha x A sine beta x plus B cos beta x. So these are three types of solution considering the types of roots that you obtain from the characteristic equation. So how can we identify this solution? By looking at the value of roots that you obtain from solving this characteristic equation. Okay, now let's take a look at the first example. So we have here y double prime okay, y double prime plus 5y prime plus 6y. So our first step is to change to characteristic equation where we have y double prime becomes m squared plus 5m plus 6 equals to 0. Okay, remember this is what? This is quadratic equation. So solving this quadratic will give you what? The roots. What are the roots? Minus 2 and minus 3. Okay. So solving this quadratic will give you m1 equals to minus 2, m2 equals to minus 3 or vice versa. Then if the solution of the quadratic or the characteristic equation are real and distinct, then your solution of this linear homogeneous second order differential equation is given by y ae to the power of m1x plus be to the power of m2x. Is that clear? Okay, so this is how you solve it. Okay, now let's try another one. Let's try example 2. Will the expression be given in the exam? I don't think, yes. I think the form is not given. Let me check. Okay, please proceed with the example. Let me check first about your question. Yes, it is not given. Right. Okay, done. Right, so changing to characteristic equation will give you m squared minus m minus 11 equals to 0. Okay, and your m1 is 3.8541, or you can write them in terms of fraction 1 plus 3 third 5 over 2. Okay, some calculator will give you this answer, right? Another one is m2 minus 2.8541, or 1 minus 3 third 5 over 2. So the solution, this is real and distinct, then just substitute to the solution. Okay, clear, everyone?
Clear, Doctor.
Right, let's try the next example. Example 3. This is m squared plus 6m plus 9 equals to 0. Will give you m is what? M is minus 3, right? Both m1 and m2 are equals to negative 3. So this is real and equal. Then your solution for this type is y equals to e to the power of minus 3x a plus bx. Right, very easy, right? Okay, the last one, complex conjugate. So look at example 4. Okay. Look at example 4. The answer is that where you have solving this, if you have no calculator which give you direct answer of solving conjugate, you can use the quadratic formula, right? Minus b plus minus b squared minus 4ac over 2a then. Okay, so solving this will give you m equals to 5 plus minus I. So this is in terms of alpha plus minus beta j, and you know that your alpha is 5 and your beta is 1. So just using the form of a complex solution of second order differential equation, y equals to exponent to the power of alpha x times a cos beta x plus b sine beta x. Okay, so this is 3 types of solution when solving second order differential equation for homogeneous. Okay, anyone has question? Any question? So far so good? Okay, try the next example. Okay, instead of finding the general solution now, we are given condition where you can find the particular solution. Okay, try this. Solve the differential equation. Okay, then by using the condition, you can find the values of A and B constants then. Okay, try it first. After this, we discuss. All right, got it? How to do? Okay, first you know that this is second order and this is homogeneous because the right hand side equals to 0. So when it comes to second order, okay, first you have to change to characteristic equation where it is m squared plus 6m plus 16 equals to 0. Solving this, what are the values of m? You obtain m equals to what? Minus 3 plus minus 7i. All of you got this? Okay. So this is in terms of alpha plus minus beta j. You know that your alpha is minus 3 and your beta is 7. Okay. And then when you have the value of the roots in terms of complex conjugate, so the solution should be y equals to exponent to the power of alpha times with a cos beta, beta is 7x plus b sine beta x. Okay, so we have done up until this part. Okay, in our previous example, we are just want to find the general solution of the differential equation. Now, we are going to solve basically based on the condition given. So we have the condition here. Okay, whenever it comes to condition, then we can find the value of constant A and B. Okay, in solving A and B, because we have two constants, we need to have two conditions, and there are two conditions. Okay, so the first condition, when y not equals to 1. And then the second condition, when y prime not equals to 0. So means that your first condition, okay, you have to apply when x equals to 0, y equals to 1. So just substitute here. When x equals to 0, y equals to 1. So this is 1. This is E naught. This is A cos 0 plus B sine 0. Okay, sine 0 is 0. Then you can find A equals to, so A equals to 1. Okay, second condition. When x equals to 0, y prime equals to 0. And we have y prime. Alright? So from this y, you need to find your y prime first. Just differentiate the y there. Okay, what is your y prime here? Okay, you have to apply the product rule here, right? Which give you y prime equals to exponent minus 3x minus 7 Okay, you check my answer here. Okay, same, right? So applying the condition, substitute x here with 0, 0, 0, 0, 0, and then y prime is 0. Solving this will give you b equals to 3 over 7. So now you have your a and b, then the solution is equals to y, exponent minus 3x, a is 1, so cos 7x plus b 3 over 7 sine 7x. Okay, this is how you find the solution of second order differential equation given by the condition. Okay, is that clear? Anyone has question? All right, so you can try past year test 1, the first question there. It's quite identical. Try this. It's quite easy. And the answer is given by All right. Okay, try it first. I'll give you around 3 minutes before you proceed. Anyone has problem finding the solution of this second order linear homogeneous equation? All good? No, no response. You're still doing it? Still doing. Okay, take your time. I'll give you another 2 minutes. But this is quite easy, right? Because the roots are distinct and real, okay? Where you just use the first form of the solution for this second order differential equation. Substitute to the form, okay? And then by considering the condition where you have to need y and y prime, you have to differentiate, okay? Substitute the condition to get both of the constant. So basically, when solve second order, y you need to plus with c. We have c once you integrate, right? No need, okay? No need to plus with c. Just we have both constant there. Okay, so now basically what we have been discussed up until now is just three types of the solution for the second order differential equation. So we have done with these three. Okay, there are three types of roots in solving second order differential equation for homogeneous part. Okay, before you can find the solution, first thing first, you need to convert to characteristic equation and solve this quadratic. So this is the basic idea of solving the second order differential equation. Characteristic equation, solving quadratic, identify the roots and what are the types of the roots. Okay, and then identify the solution. Okay, now let's proceed. So the next part is solving the non-homogeneous equation. Okay. So let's take a look at the notes. You have your notes together with you, right? Okay. So now, in solving the non-homogeneous differential equation, you know that, right? You know that your right-hand side function of fx is fx is not equals to 0 anymore. Okay, previously it is homogeneous, it is equals to 0, then we just can omit the right-hand side solution. Okay, we just focus on the left-hand side solution, converting to characteristic equation, solving quadratic, and then identify the types of solution. All of those are from the second part only, second left side. Okay, for left-hand side part. Okay, now what if in your right-hand side part, you have another function, you have fx. So you need to consider the solution for the right-hand side part, right? So how? Okay, that's why we call it as a non-homogeneous. We are going to consider both sides of equation, left and right. Okay, so in solving this non-homogeneous equation, okay, the solution is given by yx equals to yh plus yt. where YH is the solution for the left-hand side part, where it is the solution of the homogeneous equation. Just considering when right-hand side equals to 0. And then YP is called the particular integral, where this is the solution for the right-hand side part. Okay, you remember? In finding the solution of second order differential equation, if you have two equations, then you just combine both by using apa tadi? Linearity super principle. Linear superposition principle, right? Okay, by using linear superposition principle, you just can combine both equations. Okay, for the left-hand side for homogeneous and for the right-hand side for particular integral. Okay, so now how can we find the solution of the left-hand side part? Just same with the previous solution that we did in homogeneous. Now, let's focus on how can we find the solution of the particular integral for the right-hand side part here. Okay, so there are two methods to determine YP. Method of undetermined coefficient and method of variation of parameters. Okay, let's just proceed on the first method first here. So now, in using method of undetermined coefficient, okay, we are going to consider four cases. All right, there are four cases that we need to consider in finding YP, the particular integral, the solution for right-hand side part, YPX. Right. So the first case, when your fx is a polynomial. Okay. Second case, when your fx is in terms of exponential. Third case, when your fx is in terms of sine or cosine. And fourth case is when your fx is sums of the above cases. Right? So, for this method of undetermined coefficient, we just need to consider either polynomial or exponent or sine or cosine. Okay? What if we have in terms of tangent? What if in terms of secant? Okay? We cannot use this undetermined coefficient. That's why we have another method, variation of parameters. Okay, let's just focus on this one. Okay, so now let's take a look at the first example. We have polynomial. Case number 1. Polynomial. Okay. So what is polynomial? So polynomial is a function in terms of an x to the power of n, an minus 1, xn minus 1 up until a naught. So what are the example of polynomial? We have what? We have linear, we have quadratic, we have cubic. Okay, these are all polynomial up to the power of n. Okay, if you have y, a x to the power of 7. Okay, for example, so these are polynomial, okay, where n has the highest degree. So now, if we have this kind of polynomial, all right, let's consider the first case, and then your yp is x to the power of r, cn xn plus cn minus 1 xn minus 1 up until plus c naught. Okay, we need to choose the smallest r, and then chosen to ensure that no term in YP is similar to the terms in corresponding YH. Okay, now let's take a look at the example. So let's discuss this through the example. Okay, look at your notes. We have example 6 there. Can you see it? Or is it too small? Okay, so let's take a look. We have y double prime plus y prime minus 2y equals to 2x squared minus 4x. Okay, so this is an example of non-homogeneous linear second order. Okay, how can you know that this is non-homogeneous linear second order differential equation? Because there are functions in the right hand side. Okay, where your fx here does not equals to 0. When your fx does not equals to 0, then it is non-homogeneous. And then considering what are the types of function there. So this is 2x squared minus 4x, which is quadratic equation. And quadratic equation comes from the polynomial form. Okay, so first, what you can do to find the solution is to focus on the left-hand side part, where in solving the left-hand side part, it is as same with solving the homogeneous equation. Okay, let's just assume that the right-hand side equals to 0. So, changing to the characteristic equation, we have m squared plus m minus 2. Solving this, find m, you have m equals to minus 2 and 1, which are real and distinct. So this is the solution for homogeneous part, YH. So next, we want to find YP. And this is polynomial. So how can you find the solution of polynomial part? Okay, let's take a look at this. When your function is a polynomial, then your YP is XR times Cn Xn up until plus C naught. So as you can see, what is n? N is the highest degree. And the highest degree here is 2. So your YP is, your YP equals to XR C2x squared plus C1x plus C naught. Okay, you need to use the full form. Understand or not? Okay, so now choose the smallest r, where r is from 0, 1, 2, and so on. Okay, so that we need to ensure that no term in YP is similar to the terms in YH. Okay, so first, right, first you know that your fx equals to 2x squared minus 4x, where this is a quadratic and this is a polynomial. Then ypx equals to x to the power of r c2x squared plus c1x plus c naught. Okay, then we need to choose the smallest r. When r equals to 0, then yp equals to c2x2 c1x plus c naught. Okay, when r equals to 0, then yp equals to c2x2 plus c1x plus c2, plus c naught. Then you need to check to ensure that no term in yp is similar to the terms in the corresponding YH. What is YH? Okay, now YH is AE to the power of minus 2x plus BEX. And this is x squared, this is x, this is constant. So, we can decide that no similar term between YH and YP. Okay, because this is in terms of exponent, this is in terms of quadratic, linear, and constant. So no similar term. So when it is no similar term between YH and YP, then we choose R equals to 0 here. We choose this YP here as your YP. Understand or not? So this is your YP. That's why your YP is this one. Clear? Any question? No. Okay, so now we have your YP. Okay, we have your YH. But we need to solve what is our C1, C0, C1, and C2. So how can we solve? Okay. Next is looking at the differential given. Okay, we have y double prime plus y prime minus 2y equals to 2x squared minus 4x, right? And you have your yp equals to c2x squared plus c1x plus c0. So you have to merge with the differential equation here, where in this differential equation, you need to have y, you need to have y prime, and you need to have y double prime. So what is your yp prime? What is your yp double prime? So your yp prime here equals to yp prime here equals to 2c2x plus c1. Yp double prime here is 2c2. Then, once you get this, you need to substitute to the differential equation. So, y double prime is yp double prime. Y prime is 2c2x plus c1. Right. And minus y here is 2c2x squared plus c1x plus c0 equals to 2x squared minus 4x. Right? Okay, now expand and rearrange and you compare left and right hand side. Okay? Alright, let's take a look. We have here 2c2 plus 2c2x plus c1 minus 2c2x squared minus 2c1x minus 2c0. Rearrange. We have minus 2c2 x squared minus 2c1 plus 2c2x, and then the rest is constant, minus 2c0 plus c1 plus 2c2. Okay, so you rearrange this and compare. Compare with what? With 2x squared minus 4x. How can you compare? So how can you compare here is, for those with x squared, compare with x squared. Oh, sorry. Okay. For those with x squared, compare with x squared. So minus 2c2 equals to 2. For those with x, compare with x. So minus 2c1 plus 2c2 equals to negative 4. And then the rest is constant. Compare with constant. There are no constants. So minus 2c0 plus c1 plus 2c2 equals to 0. So solving these three equations will give you the values of c0, c1, and c2. Is that clear? Where your c0, c1, and c2 there is given. Quite long process, but it is doable. Okay. So this is your solution. Solving this, c2 equals to negative 1. c1, solving this, you get 1. And c0 is minus 1 over 2. So now, when you obtain the values of c0, c1, and c2, remember that this is your yp. So your yp becomes minus x squared plus x minus 1 over 2. So the final answer should combine both YH and YP. So your YH is AE minus 2X combined with YP. So this is how you solve non-homogeneous differential equation. Is that clear? Yes, we compare it with fx. The fx given here is 2x squared minus 4x. Okay, any question? Try to understand the process first. We start with finding YH and then we identify what is your case for particular integral. Then you decide that it is polynomial. Check the value of R. Okay. Finalize the value of R when there is no similar term between YH and YP. Once you obtain your YP, merge with the differential equation given. So differentiate and substitute. And then you compare with the right-hand side function. Any question, guys? Clear? Right, good. Clear. Okay. Now, can we proceed? Homogeneous? Is this the shortest way to solve non-homogeneous? Yes, because there is no condition given, right? When you have a condition given, then you need to solve the values of A and B. There is still constant there, right? So usually it is longer compared to this. Okay? But this is only for polynomial. Okay, we have many types of undetermined coefficient. Okay, let's try another example. Still polynomial. Okay, let's do this one by one. Right, what is your first step? First, you need to focus on YH, right? Okay, let's focus on this example. What is your first step? Finding YH. Finding YH means you need to convert this to characteristic equation where it is m squared plus 2m equals to 0. Okay, solving this will give you m equals to what? M equals to 0, m equals to -2. So your YH equals to A e to the power of 0, A plus B e minus 2x. So this is your YH. Right, now for YPX, look at the right hand side function. First, your fx equals to x. Then your ypx should be x to the power of r. This is a linear function. Then you just have c1x plus c0. Okay. Since this is linear, then the general form in your yp must follow linear. So it is c1x plus c0. Just like previously, your fx is 2x squared minus 4x. You know that it is quadratic by looking at the highest degree, which is 2. So the general form of yp should follow c2x squared plus c1x plus c0. Why we have x to the power of r there? Because we need to make sure that there is no similar term between yh and yp. So now, let's check. Is there any similar term between YH and YP? So first, when R equals to 0. When R equals to 0, so your YP becomes x to the power of 0 is 1, C1x plus C0. Okay, is there any similar term between YH and YP? Let's check. Is there any similar term between YH and YP? This is your YH. And this is your YP. Okay, anyone want to try? Is there any similar term between YH and YP? Similar means what? Similar in terms of form. Okay, let's take a look at the previous one. YH is AE minus 2x plus BEX. YP is C2x squared plus C1x plus C0. This is exponent, this is exponent, this is quadratic, this is linear, this is constant. So no similar term. But now, we have YH, A plus BE minus 2x, and YP, C1x plus C0. So this is constant. This is constant. This is constant. So yes, there is similar term. So if yes, what should you do? You need to proceed with the next value of R. So when R equals to 1, then your YP becomes x to the power of 1, C1x plus C0, which gives you YPX equals to C1x squared plus C0 x. So is there any similar term between YH and YP? Do you understand, guys? Okay, so is there any similar term now between YH and YP? You don't know? Anyone? Anyone want to answer?
No similar.
No, right? Yes, no. This is constant. This is exponent. This is in terms of quadratic. This is linear. So no similar term. Then this is your YP. So we choose this as your YP. Okay, this one cannot. All right, that's why you need to test the values of R. Okay, now you have your YP. Then your third step is to match with the DE. The differential equation is given y double prime plus 2y prime equals to x. So you have your YP. Okay, YP equals to C1x squared plus C0 x. Then you need to match with the differential equation. So you should have your YP prime and YP double prime. YP prime is 2C1x plus C0. YP double prime here is 2C1. And then substitute to the differential equation, which give you 2C1 plus 2 times 2C1x plus C0 equals to x. Then you compare. For those with x, compare with x. So we have here 2C1 plus 4C1x plus 2C0. Okay, compare. For those with x, compare with x. So 4C1 equals to 1 and the rest is constant. So you can have C1 equals to 1 over 4 and then C0 equals to 1. Okay? What is your C0 there? Minus 1 over 4. Now you have your C0 and C1. Then YP equals to C1 is 1 over 4x squared minus 1 over 4x. So the final solution should be yx equals to yh plus with yp. Just combine. Okay? So this is the general solution of this non-homogeneous differential equation. Alright, is that clear? If one portion is you made mistake, then the rest okay will not be marked anymore. There's still a portion for the stats, right? Don't worry. Okay, any question? So compared to the previous example, this is quite shorter because the function is only x, linear. Okay, the previous one we have quadratic, but this one stop at r equals to 0. This one stop at r equals to 1. Depends on the function that you compare. Okay, is that clear? Anyone has question?